Hello out there to you. In this video, we're going to go over a Monopoly practice problem. Something you might run into on a AP exam or a college level exam. So we've got demand, we've got marginal revenue. Marginal revenue is the rate of change in the total revenue function. So as I lower my price, I sell more units. That changes total revenue. And so the rate of change is marginal revenue. So the first question here is profit maximizing output and profit maximizing price. This is really what would the monopoly like to do. It would like to produce where MR equals MC. So whenever you see that, that's what you're looking for. So we're going to go marginal revenue down to where it hits marginal cost. Okay. If it helps you, and it makes this easier, color these curves so that you can see kind of where they cross. So here's the marginal cost, and here's marginal revenue. So they cross at 15. That is the output. Then we say to ourselves, what's the highest price we can charge? So you follow that all the way to the demand curve. We're allowed to charge $32 if we want to sell it for 15 or if we want to sell 15 units. So 32 would be the profit maximizing price. And then next, profit max profit. Okay, so you got two ways to calculate this. One is find total revenue, which is price times quantity, and then subtract total cost, which is average total cost times quantity, and you get that difference, and that'll give you a profit. I would rather do it this way. I would rather take the per unit profit, which is the difference between price and average total cost, and then multiply that by the number of units, which in this case is 15. This is easier to me. I think I might be able to do it in my head. So the price was 32. The average total cost, follow that down here, that's 25. And so that would be a difference of 7. And if we want to shade that, we can actually shade it right here. So follow that down here. Sometimes you're asked to shade things. So this would be their profit. Okay. And we're good there. So 7 times 15, I think that's 75, but let me make sure. I want to make sure. 15 times 7 is, well, good thing I did because it's 105. So 105 would be the profit. Okay, $7 each, and we're going to sell 15 units. Now, if the above market is regulated to the welfare maximizing, so this means that we're going to go to where demand equals marginal cost. It might also call that allocatively efficient or no dead weight loss or socially optimal. Okay, so for that, you're going to go to where marginal cost and demand meet. So that quantity would be 28. And the price in that case would be also 28. And then the profit, so now we're going to look for the difference between here and here. So it's about, we don't have an exact number. Let's say that was 24. So it'd be like 4. So follow this over here. So it'd be like $4 per unit. And we're doing that on 28 units. So 4 times 28. And it would be like 112. Now, if you think about that value, 112 is more than the profit maximizing price. So then this like can't, this is not drawn to scale. This can't be 24. Okay. This has to be some number that's much lower. So we don't really have a profit because we don't know what the average total cost is right here. So we wouldn't really know that one. All right, if the above market is regulated, what is zero profit? So this would be where price equals average total cost, sometimes called the fair use price. So just follow that average total cost to where it hits demand. And so that's going to be 25 for a price and 34. And that's it. Now, one thing I didn't color was under profit maximizing quantity up here in case you had to think about the deadweight loss. So the deadweight loss can be the difference between profit maximization and perfectly competitive outcome or socially optimal outcome. So there would be this triangle here, looks kind of linear. So it would be the difference between 1432 and out to 15 to 28. That would be your dead weight loss.